Hello world, welcome to this live Microsoft Learn session where we're going to be focusing on implementing a CI or continuous integration and CD or continuous deployment solution for Azure IoT Edge. My name is Paul DeCarlo and I'm a principal cloud advocate at Microsoft, and I'm joined here by my colleague and friend Ayse from the University of Oxford, who's going to give a quick introduction to everyone.
Hi Paul and hi everyone. I'm Ayse Mutlu. I'm a lead AI tutor in the Artificial Intelligence Cloud and Edge Implementation course at Oxford. And I have also experience for both building and teaching AI Edge Engineer learning paths in Microsoft Learn. So we are going to go through one of the modules with you, with Paul.
Excellent. And yes, just as Ayse mentioned, this module that we're going to walk through is available online at aka.ms/learn/IoT-CI/CD and was developed in partnership with folks from the University of Oxford and is a standalone walkthrough learn module that you can take on at your leisure. And we're going to show you how to follow through with this live right here on this stream today. So I do want to let everyone know that this is a live stream. So if you do have questions or you see something that perhaps you'd like additional explanation on, you can tweet us your questions on Twitter using the hashtag LearnTV. And we have a whole series of moderators who will be handling those questions in the back end, and some of them we might even surface up to the live stream that we're currently on right this moment. So before jumping into this, a few prerequisites. I'll go ahead and explain one quick hardware prerequisite. The only thing that you will need to successfully follow through today's content is a working machine, a computer of sorts with a capable internet browser. Now, as far as the services that we'll be employing, it would be nice if you have a basic knowledge of Azure DevOps, but don't worry if you don't. Ayse and I will teach you everything that you need to know to get started. In addition, basic knowledge of CI/CD or continuous integration / continuous deployment. Basic knowledge of our Azure IoT Edge runtime service, which we will also explain before getting started. And of course, in order to follow along, you will need an active Azure subscription. And for students out there, we do have an Azure for Students offer that you can take advantage of for free to get free access to the resources needed to complete this module. And finally, optionally, if you have a GitHub account, you can utilize that to sign up for the Azure DevOps service that we'll show shortly. Now, the learning objectives that we're going to cover today will involve creating a pipeline that deploys a smoke test using virtualized IoT Edge devices. And we're then going to couple that with a monitoring strategy that will allow us to employ a CI/CD pipeline to be able to perform long-running tests on an IoT Edge solution. Now, when you look at the agenda, if you followed along with the previous link, that has brought you to a Learn module on Microsoft Learn, and you'll notice that the sections in the agenda map to it 100%. And the reason for that is because Ayse and I are going to be walking through that exact content as it is on Microsoft Learn today. So there's quite a few different steps that we'll be going through. And we're going to basically walk you through end to end so that you at home can see just what it's like to create this CI/CD solution for IoT Edge devices for yourself. Now, before we get started, of course, there's a bit of content that we definitely want to lay some foundations on so that everyone out there is on the same page and understands some of these core concepts that we'll be introducing. So the first one is, of course, the concept of Internet of Things, which I think a lot of us have different interpretations of. Ayse, how about what do you think of when you think of Internet of Things? How would you define that for the audience?
So I can define IoT or Internet of Things as a network of physical objects or things which have embedded electronics, network, and sensors that receive and collect the data. And here also I want to mention about the edge computing. While IoT is interesting, edge computing allows you to use IoT to deploy many different applications on the devices. So with the IoT Edge format, you can move your cloud workloads to the edge of the network. And by doing this, you can reduce the communication with the network and improve the latency. And even if necessary, you can run it offline, so which is essential for IoT devices.
And that's amazing stuff, especially as we move into this AI-driven world where we talk about, perhaps AI workloads running at the edge that are performing insights in real time. Now, we're going to couple that with another school of thought, if you will, that we refer to as DevOps. And again, this is something that might be new to folks. So, how would we really quickly introduce this concept, which is it's a big world here? Well, how would you define DevOps, Ayse?
So DevOps comes with two words, development and operations. And in a short definition, DevOps is the process of combining the software development cycle with IT operations. And there are some special synergies between DevOps and IoT, especially when it comes to running AI applications on the devices. So you can easily extend the benefits of DevOps to the edge devices.
Well put. And again, when we talk about this DevOps concept, a lot of folks who might have familiarity here might have noticed that there are some similarities across successful DevOps solutions. And those typical ingredients will include things like version control systems. So if you've heard of things like Team Foundation Server or Mercurial or the really popular Git, that is one of the version control systems that would allow you to track code changes as they come in. Similarly, we'll look at something called continuous integration, which will allow us to validate code before we bring it into our version control system. So being able to check that code successfully compiles or passes tests before we allow it in. And that's very similar to continuous deployment, which allows us to take code at the moment that it's checked in and then allow that to get shipped down to a device, whether that's a QA test device or perhaps even an end user, or maybe even go right out to production to someone who might have one of these devices inside their home if it's a product that you buy off the shelves. And all of this is, of course, wrapped around with the concept of testing, so doing things like unit integration and load testing. And this can allow you to facilitate quality in your release management. So always ensuring that, I guess, whatever code that you are shipping, in fact, works and is going to run successfully on the target device. Now, when we talk about these two concepts in the together, and you sort of look at what happens when you combine DevOps with IoT, it's not always immediately apparent like what the challenges are with that or what the benefits are that this brings, because we're dealing with real devices, and how do you scale that out? So Ayse, do you have any additional thoughts here on like what happens when we actually merge these two fields together, and what does that look like?
So when I could think of DevOps for IoT, so when you actually get the code down to the device, especially this could be thousands of devices in the field, and you want to make sure that your program is working successfully and working in a secure and safe way. And just think about your models deployed on the devices, and they need to be refreshed and deployed frequently. So for these reasons, we have many challenges, and with the deployment, testing, and release management.
Absolutely. And what I like here, we're going to kind of demystify those challenges and hopefully show you how you can do things like that using a generic pipeline that we're going to create in just a few moments. Now, we've talked about this, it's kind of in the title of the session. It's very important that we are utilizing something called Azure IoT Edge. And for folks out there that don't know what this is, it is essentially a container orchestration runtime that allows you to pull down workloads that you would run on an edge device in the form of containers, and we refer to these as modules. And within these modules, there is support for first-class SDKs that can communicate with the Azure backend services. And these support first-class languages like Python, Node.js, .NET Core, Java, and C. And ensuring that we can get our data from the device to the cloud in the fastest way possible, we do employ such data transport mechanisms as AMQP and MQTT. And if you're wondering, maybe I have a device that's perhaps legacy and it's, doesn't have a lot of memory, perhaps it's just a microcontroller, and you're wondering, how can I connect that to Azure? The great thing about IoT Edge is that it can be configured to run in a gateway platform that will allow you to then connect legacy devices, or you can create custom modules to transmit that type of data into the cloud. And what's great about this, I should mention this earlier, is that since we're using containerized workloads, we can operate in offline or even intermittent network conditions. So you could think of if you're offshore and perhaps you'll lose connectivity to the internet, you can still be running your workloads. And then when that network environment regains access, you can then dump all of your cache telemetry up into the cloud. What's really interesting, this workload can be run essentially, or the platform itself can be run on Linux on x64, ARM32, ARM64 platforms, or Windows on x64. And the entire project is open source and available on GitHub at github.com/Azure/IoT Edge. Now, every IoT Edge device is going to be supported by a backing service in Microsoft Azure that we refer to as an Azure IoT Hub. And this not only gives you the high throughput mechanism to be able to ingest those AMQP and MQTT messages. In fact, it can handle up to 1 million events per second, but it also allows for secure registration of devices to ensure that only authenticated devices are able to push data into this backing service. And what we're going to see, and what will be quite a big focus of today's presentation, is the IoT Hub can also store a deployment, which is essentially a specification that outlines which containers or modules we'd like to ship down to our IoT Edge runtime-enabled device. Now, what this will look like is that we're going to utilize Azure DevOps to use a publish IoT Edge deployment task, and that's going to create a deployment that will live in an Azure IoT Hub. And from there, we can start to create target criteria. For example, if a device is a quality assurance device, or one that's in the East region or the West region, and be able to apply that deployment based on that target criteria. And once we have that all set up with a pipeline process within Azure DevOps, that's going to allow us to take code changes from multiple developers, be able to bring those into developer branches where they can be validated there, and of course, being able to validate them when they go into a master branch, and then connect that to a controlled release pipeline where we can ensure that the deployment that we are sending out to perhaps our production devices or our QA testers is in fact good to go and able to run on the device. Now, in summary, what we're going to essentially do throughout this module is implement a solution that will allow us to smoke test using CI/CD with virtual Azure IoT Edge devices within an Azure pipeline, and we're going to back that with something called Azure Application Insights to be able to monitor those workloads when they get shipped down to our virtual device. So we're going to start by giving a bit of background on designing a CI/CD pipeline for IoT Edge, and then we'll get started with our first exercise. So one of the interesting things about an automated CI/CD strategy is that it addresses a couple of problems. For one, we can create a smoke testing strategy for our IoT Edge devices, meaning we can actually validate that our deployments are good before we ship them out. And we can also facilitate integrating code from several developers in an automated process, as you saw on the previous slide. Now, some of the benefits of this testing strategy might not be apparent. So Ayse, would you like to share with the audience how we might be able to get benefit from using a smoke test strategy for this particular solution?
So yes, when we are using a smoke testing, we are deploying to virtual IoT devices, and it is cheaper than having a physical IoT devices. And when we do a smoke test, we ensure that our program is running successfully and it is ready for further testing. And by automating the smoke test, we can avoid the expensive rework, and we can optimize the time for developer and the test teams.
When I'm hearing you say this, it sounds like this saves a lot of money because we don't need to get devices, yet we can still use this to do load testing. For example, we're going to show later on before the end of this presentation, you could have X number of devices pointed at an IoT hub and be able to start simulating them to push data and to perhaps test third-party integrated services. And I just love this, the optimizing time for developer and test teams, because saving time is saving money. And I just love that this solution really streamlines that quality in a productive way. So let's start with the first section where we're going to look at creating a CI pipeline with Azure DevOps. And this is going to allow us to utilize something called pipelines, which will support continuous integration and continuous delivery. And we'll do this by defining a build pipeline that will be created specifically to build and test our code and publish those artifacts off. The artifact in question being a deployment manifest that will specify what we want to run on our edge device. And then we're going to couple that later on with a release pipeline that will allow us to consume and deploy those artifacts to specified targets. So let's go ahead and get started with the first exercise, where we're going to create a CI pipeline for IoT Edge with Azure DevOps. Now, the first thing I'm going to do is navigate back over to our Learn module, and this link again was at aka.ms/learn/CICD IoT. And we're going to go ahead and scroll down here to the first exercise. I'm going to be kind of jumping in and out here of the exercise sessions as we sort of go back and forth in the browser and presentation. And let's go ahead and get started with this first section. So we're going to go ahead and create Azure resources. So it says to do this, we'll click on the Deploy to Azure button. Now, what this is doing in the back end is it's going to spin up something we call an Azure Resource Manager or ARM template. And this is going to essentially specify all of the services that we need to create the CI/CD pipeline. It's going to go ahead and do that for us. Now, there's not too much to really do here other than specify the resource group that we want to put this in. And that's essentially a logical grouping of all of the resources together. It's just one way to sort of hierarchically recognize that these things are all related. Then what I'm going to do is change this to a region that's a bit closer to me in the East US. And there's one value that it asks here. It says resource name suffix. And what this means is that all of the services that are going to get created, it's going to append the text mslearn CI/CD at the end there. So we'll go ahead and click the next review create button. And hopefully we get a green check mark. And Ayse, does this look good to you? Are we ready to go ahead and deploy?
Yep, we are ready to go.
Excellent. So I'm going to go ahead and click the create button. And this is going to spin me off into my Azure subscription where you'll start to see that deployment go underway. Now, what I really find fascinating about these ARM templates is how fast they can be. It does, of course, depend on the types of services that you are employing. But what we're going to see here in just a moment is it's going to spin up quite a few different services for us. Now, I did get a mention here that we might have a frozen video here. So what I'm going to go ahead and do is reshare my screen for folks out there. This shouldn't be too big of an issue. Go ahead and stop sharing, and we'll start that again. I don't think we're going to lose any time here. Excellent, and it looks like that should be fixed for folks out there in the internet world. So you should see here that it's created a few different resources, the first of which is a container registry, where we're going to store our container workloads that we're going to build from source within our pipeline. And similarly, I've got myself an IoT Hub. Again, that is that backing service within Microsoft Azure that is essentially going to handle all of the telemetry messages and the registration of our devices. And finally, if you look here, there's an App Insights component that we're also deploying, which we'll use later for monitoring our solution. Now, we'll give that a few minutes to complete and continue on with the additional portions of this particular exercise. So the next thing we're going to do is go to create an Azure DevOps project. Now, for those of you that don't have an Azure DevOps account set up already, you can navigate to the link here and start free, either with an existing Microsoft account, or if you've got a GitHub account, and everyone's got one of those these days, you can use that as well to go ahead and get started. Now, I already have a DevOps instance that's been created, so I'm going to go ahead and create a new project within that instance to facilitate the rest of these steps. So it says here that what we're going to go ahead and do is open up our project, and we're going to create an organization, of which mine already exists. Then we're going to go ahead and create a new project. So I'll click here, and I'm going to go ahead and give this a similar name to before, the mslearn CI/CD, and I'll go ahead and click create. Now, you might get different options here. I was given the enterprise and private, depending on how your account is set up. So I'm working under a corporate account, so it's going to give me those options, but you might also be able to create a public one that you can share with other individuals. And now that that's up and running, what we're going to do is go ahead and import some code into our project. Now, it kind of gives us a little bit of a clue here that we should maybe do that. I'm going to go over here on the left, and there's a section here for files. And when I click on that, you'll notice it says, hey, this repo is empty. Let's go ahead and add some code. So I'm going to copy the link to this repo. And what this repository is actually created in partnership with the University of Oxford. And it's going to contain really similar steps to what we see in the Learn module and be almost a self-documenting way to be able to create this pipeline, as you'll see in just a moment. So let's go ahead and bring that in and select import. And we're going to use a Git type repository, paste in that link. We don't need authentication, and I'll select import. And this will take just a moment, and you should see it will essentially mirror all of the content that you see here in the IoT Edge DevOps project will then get mirrored into our Azure DevOps instance. So go ahead and click here to view the code. How's things look here, Ayse? It looks like we brought everything in correctly.
Yeah, we got the code to the. Our
Perfect.
DevOps. Yeah.
And I just got a notification on my phone that says import successful, so that is great. We know we've got what we need. So the next thing we're going to do is create the CI pipeline. Now, there's a little bit of understanding kind of how this works behind the scenes and in terms of how this works. We're going to edit this file, this .azure-pipelines.yml file. And the reason why is that Azure DevOps will actually see a file of this name. If it notices that, it will use it as a build definition. So we call this build as code, and we're utilizing the YAML syntax to specify different tasks available in Azure DevOps that will enable us to build our IoT Edge solution. Now, this will be a little bit more clear when we get into the visual editor in our next exercise, but for now, we're just going to continue following along, and I'll try to give a little bit of background explanation on what's working under the hood. So we're going to go ahead and add a comment to our file. I'm just going to go ahead and add that to the top here and commit that change. And now that we've made that first commit, when I head back over to my files section, that same thing we were just looking at, there's now an option here to set up a build. So I'm going to go ahead and click on that. And again, it sees that Azure Pipelines.yml definition, and it says, hey, that's a build definition. I'm ready to go ahead and build this for you, and gives me the option to run. So let's go ahead and do that. And this is going to kick off that first build. Now, I've obviously rushed myself here and did not read ahead on the instructions. So I'm a little bit curious on how successful this might be. But for those of you out there, what's happening behind the scenes is Azure's actually spinning up a virtual machine that's going to run the workload that's going to create the environment that will pull down our source code and actually start building out the modules that are defined in our project. Now, it looks like I've done something wrong here, Ayse. I'm getting a few warnings. Any suggestions here on how I might be able to fix this?
Yeah, this fails is to be expected actually. So because we forgot to add our variables to the pipeline.
Excellent. You've caught me slipping again. You know, all of the documentation is here in the Learn module, and it looks like what I've done is just not actually read the instructions. So again, for those of you out there, all of these documentation steps are captured in the Learn module in question at aka.ms/learn/CICD-IoT. Now it says we need a few things here, this ACR host, ACR user, and password. Now, what I'm going to go ahead and do is show you exactly where we can obtain these variables, and I'm going to add them into a notepad document that will essentially keep them all together, because we're going to reuse them throughout the session today. So the first thing I'll do is go back to my deployment that completed, and we'll select Go to Resource Group. I can click inside here, and the first thing I'll do is select my container registry. And from here, to get access to the ACR host, ACR user, and password, I'm going to go to Access Keys, and I'll bring over a document. Now, part of this is filled out already, and I will explain that as we go along. We are going to go ahead and copy the registry name, the login server will become the ACR host. The username will become the ACR user. And then the password will go ahead, and this did not exist until we created it, so I'm going to go ahead and copy that in. And finally, we're going to need to grab one more thing called an Application Insights Instrumentation Key. So that's everything we needed for the ACR host, user, and password. To get our App Insights key, I'll select the App Insights instance, and there it is right there. Now, you'll notice maybe that I'm using a different key here. And the reason is, in the instance of time, we have 1 hour to present. We're going to make sure we can get all the way to the end. And in order to do that, I've got some things that are already set up with an existing instrumentation key. But don't worry, this will not detract from following the steps from scratch, essentially. You'll still get that same experience here. So we've got everything we need. Let's go ahead and head back to our pipeline where we can see, oh, yikes. Looks like it failed. So go ahead and check that out. That's a mess. Okay, well, good news is we can go ahead and edit our pipeline. So I'm going to go ahead, head back to pipelines, click here over on the right on the 3 dots and select edit. And from here, there's a section where we can add variables. And I know that we're going to add these 4 variables here. So I'm going to go ahead and add the value for ACR host. We'll go ahead and save that. I'll go ahead and create one for ACR user. And as you all excitedly watch me copy and paste these values in, we'll just continue on through with the ACR password. And finally, our App Insights instrumentation key. Now, I do want to mention to folks out there that if you have questions, feel free to send those over to us on Twitter with the hashtag LearnTV. We do have moderators that are watching those channels and answering your questions in real time as they come across. So let's go ahead and hit save there. And Ayse, now that we've got the variables, does everything look good, you think, to go ahead and kick off a new build?
Yep, let's start the building.
Excellent. Now, hopefully, I followed the instructions right here. We're going to go ahead and kick off this build on the master branch, and we'll go ahead and click run there to kick that off. So, in following additionally through the steps, we did jump ahead a little bit. We did get our variables. We showed you where to get those, and we edited them, kicked off our pipeline. The last thing we need to do, and was kind of the whole point of this section, was to add continuous integration. And so to do that, I'm going to go navigate back to my build. We'll go over here to the repos section and branches. And over here, I'm going to see my master branch. We can see we've got a build in progress. That's cool. I'll click on the 3 ellipses and go down here to branch policies. And once I do that, all we have to do to enable continuous integration is go down here to build validation, select the plus to add a new build policy, and really the default options give us pretty much everything we need. What this will do is it will enforce that any pull request that comes into master must first succeed a build step, and then once it's been merged, we'll let it live for about 12 hours and then we'll delete it. Does that sound good, Ayse?
Yeah, that's perfectly well explained.
Excellent. So let's go ahead and save that, and that's it. Now if we get another developer to come into this project and they start submitting their code, we'll be able to easily validate that it builds and passes perhaps any tests that are in our pipeline before we accept it into the branch. Now, that's the end of our first exercise. And I've got a question for everyone out there. So those of you who are tuned in and watching live, which function does CI/CD or continuous integration / continuous deployment enable us to perform? And we've got 3 options here. Give y'all just a few moments here to put your answers into the live chat. And Ayse, let's go ahead. Let's hear from you. What is the proper answer to our question here?
So CI/CD performs unit testing, but what we want regularly and consistently test, build, and ship the code.
That is correct. And you'll notice really all of the choices here have some mention of testing, but the whole point of CI/CD is that we can do this consistently. Every time the developer checks in that code, we are going to test it before we accept it, and that is correct. So again, give yourself a pat on the back if you got that question correct. So next we're going to look at how we can create a release pipeline with a smoke test. And now what we're going to do is utilize a containerized instance of an Azure IoT Edge device. We're going to configure this as a QA device. And once we stand up that device and register it with our IoT hub, we're then going to expose it to a script that will probe it to look to see if it's applied the correct deployment. And once it verifies that, it will go one by one down each of the modules specified in that deployment to ensure they're all there. Now, you might be wondering, like, what exactly is that going to look like? Well, if we look here at the actual syntax or structure of a deployment template, in our previous example, we had leveraged a plugin in terms of our pipeline. It was a replace variables task. We might have gone over that very quickly. Now what that's doing is it's looking at any values that are present here that are preceded with a hashtag and open bracket, and it will replace them with a value that we have specified. So if you recall earlier, we forgot to add variables and everything was broken. That's because if these values aren't filled in by our build definition, then the build won't succeed. And this definition goes through to define all of the modules that run on our device. The system modules, which include something called an Edge Agent and Edge Hub, and our custom modules, which include things that we're pulling from public repos, as well as one that we're building from source. We're also going to modify something in this module.json section. This is going to allow us to tag any built container images with the exact build definition name and build ID that come from Azure DevOps. Now, if you're not able to follow along with this just yet, I promise you this will make sense when we jump into the visual editor in just a moment. Now, we're going to go ahead and move on to this second exercise here, where we're going to create a continuous deployment release pipeline for IoT Edge that's also going to employ a smoke test. So hopefully everyone out there is excited. Now, what I'm going to do here is I'm going to head back to our core part of our module and head to the second exercise section. And you'll see here that the first thing we're going to do is create a new release pipeline. Now, it's a little bit of a catch-22 because we're going to import one that we've already created, and you can't do that until you've created one already. So what that means is we're first going to head over to our pipeline section, go to releases, and what we're going to do is create a new pipeline. And we really don't want to do anything with this pipeline. We're only creating it so that we can get the option to import. So I'll select the empty job. We'll go ahead and save that. And we'll use the default settings there. And now that we've saved our first release pipeline, when I head back to the section on releases and we navigate over to this new section, there's a new option here to import a release pipeline. So again, before that was sort of telling us to create one. Now that we've created one, we can import one. So let's go ahead and click import. And I'm going to browse to the source code essentially for the Oxford project that you had saw earlier. And we're going to go ahead and import an existing release pipeline. So we'll import this release pipeline.json. And once we've done that, we'll be presented with the following. So we've got kind of a skeleton here, but something looks a bit amiss. Ayse, I'm sure we probably need to go ahead and look at these red sections here. This looks like something.
We have a few more fixing.
So we can't just automatically bring it in, but we're going to get close there. So let's go ahead and consult the instructions again. And what we're going to do is first head to our first task. And this is the create deployment task. Now, what's interesting here, this task actually looks almost identical to the YAML build as code definition that we saw earlier. But you'll notice in this visual form, it's a lot easier to make sense of it. So we'll start to explain things a little bit here. We're going to build a pipeline that is going to replace the tokens that we saw in that deployment manifest that we were looking at, as well as the module.json file that we explained. And we use built-in tasks from Azure DevOps to build our module images, including the modules we're building from source, push those into the Azure Container Registry that we deployed at the beginning of this session. And then we're going to create the deployment that will live inside of our IoT hub that will be referenced by our IoT Edge devices. So just as Ayse said, there's a few things we're going to need to fix here. And if we go ahead and look at those sections, we need these bottom two. We're going to go ahead and update those with our Azure subscription. And that makes sense. We need to go ahead and authorize it so that it can actually push modules into our Azure Container Registries in a secure fashion. So we'll go ahead and click the authorize button here first. We'll go ahead and give that just a moment to complete. And there we go. Once we've done that, we can refresh our Azure Container Registry entries, and you'll see there's that container registry we created at the start of the presentation. So that took care of that one's issues. Let's go ahead to the next one, and it looks like this one's similar. Let's go ahead and select the subscription that contains the IoT hub in question. Red's gone away there. Now let's go on to the smoke test. And if we follow the instructions, similarly, we've got two sections here that we need to update. So I'll go ahead and update the remove all QA devices. Now, why we're doing that, we want to make this so that this pipeline works in perpetuity, so you can always execute it and it will always work. So we're going to assume our QA devices are ephemeral and don't need to always be there. So every time we run this, we'll delete them, and we're going to create a brand new one from scratch. And then we're going to create that Azure IoT Edge device instance. This is going to create an instance of the Azure IoT Edge device container, which is our virtual Azure IoT Edge device, and is also a project that's available on GitHub. From there, we'll give it 30 seconds to register itself with the IoT hub, and then we're going to expose it to our smoke test. And this will essentially start asking it, have you applied the deployment in question? Has that deployment pulled all of the associated modules successfully? Were they able to start running? So we've done that, and there's still just a couple things we need to fix here. You'll notice that this agent job section is in need of update. And this is essentially telling our pipeline what type of machine we'd like to run this on. So I'm going to go ahead and check the Ubuntu 1604 Azure Pipelines hosted image. Now, we just got a really great question from the audience that is, so what is a smoke test? Well, if you've ever heard the saying, where there's smoke, there's fire. I think that's kind of where it originates from. We're going to go ahead and apply our deployment and see if any smoke essentially comes out. So if anything blows up in the process, that will be able to inform us on whether we have successfully created a working deployment or not. Now, the second thing that we have to update is also in the create deployment step. We need to also update to the agent pool configuration there as well. We'll also set that to Ubuntu 16.04. Now, I'm having flashbacks to how we broke the last build, Ayse. I have a feeling there's one more thing we need to do, and I haven't been reading the instructions. What would you suggest here?
Yeah, we need to add variables for the release pipeline as well.
Excellent. And this is going to look a little different, right? Like, and I kind of like this. It's harder to mess this up. So instead of having to add them and go back and forth, they're all right here. So we're going to similarly start adding in variables here. And you're going to notice there's a few new ones here. This IoT hub name and SP app URL, which stands for service principal. I'll start filling those in, and then we'll go ahead and explain what they're going to do. So the first thing we'll do, grab all of my ACR host. We'll update that associated variable. The user, I'm sorry, we'll get the password next. And hopefully we got all of that. Sorry if I'm cut off here. Then we'll go ahead and get the ACR user. Our instrumentation key. And then it's asking us for our IoT hub. Now, if you're curious where to get that name from, we'll head back to our resource group that contains all of our resources. You can literally just look at the type IoT hub resource and just copy that name. And that is essentially the name in question. So we'll update that. And then our service principal app URL and password. Now, this is essentially going to allow us to authenticate against our Azure subscription utilizing the following password. So do be sure that if you are doing this in production, that you have an ability to control this and you don't want to necessarily share this with the world. And don't worry, this is going to get changed immediately. And then also we're going to add the subscription and tenant ID values as well. Now, because we're in our editor here, I'll go ahead and finish this up and select save. And we know that this build is going to take a while to complete. So after I save that, I'm just going to go ahead and start this. I feel very, Ayse, does this look good to you? We've got the variables. There's no red. Are we good to go?
We did everything. We are good to go.
Excellent. So let's go ahead and create that release. I'll just give the default options here and go ahead and select create. Now, going back to our steps, we've added in the associated variables as mentioned. Now, what I did not show is how to actually generate the service principal. Now, to do that will involve utilizing something called the Azure CLI, where you would just run a few commands. And for purposes of privacy, I don't want to show all the subscriptions I have access to. You run the following command to get your subscription, and then you run this command to actually create the service principal, which will give you an output that looks like this. These eventually become the SP app URL, SP password, and tenant values that we saw earlier. Now that we've configured that, it looks like we missed a step. Again, I've made this mistake. We forgot to add the artifact. And that is super important because if you don't have an artifact, well, your pipeline will have nothing to pull from. So this very likely, it looks like the way that we created this pipeline is actually utilizing something. Oh, there it goes. It's giving an error. So we'll just give that a few moments to fail. But I'm going to go ahead and edit my pipeline again, and this time successfully add the artifact. So I'll click here on add an artifact. And from here, we're going to select the latest source from the MS Learn CI/CD pipeline. So basically, it's going to pull from that master branch, latest version, and that will then become the basis of our release. So I'll go ahead and add that, save it. Now that we've updated the release, we can go ahead and create a new one. And again, this will take a while. So we'll give that some time before we come back and check on it. And that was it. That was as easy as it was for us to create a release pipeline with a fully integrated smoke test. So let's go ahead and head back to our deck where we'll ask question number 2 for folks out there that are tuned in. CI/CD has been implemented using which mechanism? Apache Spark, data stores, or pipelines? We won't give very long for this one. Everyone out there should get this one correct. Ayse, want to help everyone else out there? What's the correct answer here?
Yeah, obviously CI/CD is implemented using pipelines, which we always talk about.
That's right. We've been mentioning that quite a bit throughout the presentation. I don't think we've said Apache Spark or data stores, and those are completely different things. So if you got answer C, you are correct. Give yourself a pat on the back. So now we're going to get into our third and final exercise where we'll show how to monitor devices with application insights. Now, this is going to allow us a pretty cool functionality to be able to perform long-running tests against our Edge modules and even be able to configure real-time alerts utilizing the Azure Application Insights service. And we're going to dive right quick into that particular exercise. So again, we'll head back to the main Learn module here. And we're going to jump into exercise 3, this monitor devices with application insights. All right, and let's start with step 1. Wow, that's a big step 1. Create an Azure Kubernetes service cluster. So we're going to create a cluster that can essentially allow us to create X amount of Azure IoT Edge devices, and we're going to deploy them in a virtual format. So wow, there's a lot of buzzwords said today. We're going to show you the whole everything, DevOps, Kubernetes service, how you can configure a pipeline, all of that in just a moment. Now, I've already created the cluster, but I want to show you how you would do this on your own. So I'm going to head back to my resource group that has all of the resources we've created for the session. We'll select Add, and I'll type in Kubernetes service. And once we do that, we're brought to the following screen, and I'll go ahead and click Create. And from here, I'm going to go ahead and create a new cluster. We'll call this Kube Cluster 2. And there's a reason for that, because I've already taken the name Kube Cluster. And let's put this in a region, again, close to us. That makes sense. Now, this part is really important for folks out there. The Kubernetes version that this content was built against, tested on, guaranteed to work on, is version 1.16. Now, as you know, as time goes on, there have been updates, and the new default is now 1.17. I do want to call it and stress that this is very important. Please make sure that you use version 1.16 here. Once you've got that configured, everything else should be fine. We'll go ahead and go next to node pools. And this is essentially, you can configure this here on the previous step, what type of VM you'd like to deploy as part of your Kubernetes cluster. We're going to use DSV2 VMs. These will essentially have 7 gigs of RAM, 8 data disks, and just really a lot of horsepower to be able to throw our virtual devices at it. Once we've done that, we'll go ahead and click next to the authentication step. And this is another part that I really want to stress. We're going to disable role-based access control. Now, I don't encourage doing this in production, but when you're learning, it will make it a lot easier to actually access the Kubernetes cluster. So let's go ahead and disable that. And then we're going to use the default settings for the networking. We'll also do default settings for integrations, default settings for tags, and everything should check out here. So make sure we get a green check mark here in the validation. And Ayse, did everything look good to you? I think we're good to go here.
Yeah, it is very exciting.
Excellent. Now, I'm not going to actually push the create button, but just understand, again, we want to make sure you're using that 1.16 version and that you have disabled role-based access control. Again, don't encourage that in production, but for today's learning, absolutely encourage you to do this. So once you've done that, what we're going to go ahead and do is get the credentials to our cluster. Now, since mine's already been spun up, this should be rather easy to do. So we'll go ahead and copy this command. And again, I have a Kubernetes cluster in a resource group named Kube Cluster that's also named Kube Cluster, which is great because it makes it really easy to remember when you're presenting live. So here we go. We'll go ahead and run that command and see if that works. And what this is going to do in the background is essentially this is going to allow us to authenticate against the cluster and then be able to access it remotely. Now, there's a great question that was just asked here. It was, so once you have completed your CI/CD process, how can you move this to be fully functional and operational with monitoring? Great question, and that's exactly what we're going to show you in just a moment. So please hang tight. That was a great question from the audience there. We will show you that in just a moment. So once we've merged the security context, we'll go ahead and do kubectl get nodes to verify that we can in fact execute commands against our cluster. And as long as we're getting a result back, that makes us feel good that we're ready to go. So what we're going to do here is head back to our release pipeline, and we're going to edit it, and we're going to add a new stage here. And this stage will come after the smoke test. We're going to call this integration. So let's go ahead and head back to our pipeline editor. So let's go to all pipelines. We'll choose the release pipeline copy, and we're going to go ahead and edit that. And we'll add a new task here. And I'm going to use just a search for Helm, and this will give us the deploy an application to Kubernetes cluster using its Helm chart. So go ahead and apply that. And looks like we got a little bit of red, and I'm also going to rename this. I'm going to call this integration. But never fear, our documentation that has been well written is going to walk us through all the steps to remove the red. So let's go ahead and navigate to the task. And we're going to go to the first step, the install Helm task. And we're going to change that. Instead of using the Helm version spec of latest, we'll use 2.9.1. That should look good. And now we're going to go back and look at the Helm init and Helm upgrade tasks, because those actually looks like those needed some additional configuration as well. But before we do that, I think a little explanation. What is Helm? What are we even doing here? Helm is a package manager for Kubernetes, so that will allow us to essentially deploy pre-built charts or packages, if you will, against our cluster. And the chart we're going to use is going to specify a deployment of Azure IoT Edge devices. So let's go ahead and click on the top here where it says integration. Some settings need attention. And we're going to configure this again like we saw before with the Azure subscription. And I'm going to choose the resource group that contains the kube cluster in question, which is aptly named kube cluster, and the kube cluster itself that is named kube cluster. And these will cascade down, so you'll notice that actually fixed one of the red marks down here, but we're not out of the red just yet. The next thing that we're going to go ahead and do is head back and ensure that our agent job, which is by default configured to run on Windows, we need to update that to Ubuntu 16.04. And once we've done that, we'll go ahead and configure our Helm init task. There's just a small little thing we need to do there to make it upgrade Tiller. Tiller is a workload that gets deployed into the cluster and is used by Helm to essentially control its deployments and speak to the cluster. And next, we're going to add a new task. We're going to actually go ahead and add a step here for add new task. We'll search for bash. And this lets us run like commands, right? Like Ayse, like if you're running a command on the command line, we're just going to basically make our build do that. Sounds good?
Yeah, exactly.
So we'll go ahead and copy those commands from here and paste those in. And all those are doing is using Helm repo add to add the command, point it at this particular URL. We're going to run Helm repo list, Helm repo update. And it looks like we've just got one more step to configure. Now this one can be a little tricky, so you want to pay a lot of attention here. So I'm glad I've got a co-pilot here with me. The first thing we'll do is update the namespace to IoT Edge QA. Whoops, and then we're going to set the command to upgrade. That's cool, that's there for us. Then we want to change the chart type. Now, the difference here being, we could use a chart name. And because we executed this script that adds a new chart of name Azure IoT Edge device container, we can actually specify that now as a named option to this particular task. So we'll go ahead and add that. So there's our chart name. Finally, we'll update the release name to IoT Edge QA instead of Azure DevOps, which is given by default. And then this step I always mess up. I always put this in the wrong place. Copy the set values section, and we're going to go ahead and paste that in the set values section. Now, sometimes I just don't read. I see this value file section. I paste it in there, but I think this is good. I should Did you think that I followed these correctly? Did this look like we were going the right direction?
Yeah, we are in the right direction right now. And just one more thing left.
That's right. That's right. There is more. We need to check that the our checkboxes have been selected. So
Yes.
we'll go ahead and update the install if release not present, recreate pods, force, and weight boxes. And those essentially will allow us to, again, run this in perpetuity. So you can run this particular pipeline over and over again, and it will always work. So now that we've done that, I think that's everything. We'll save it. And this pipeline is going to take even longer than the last one, I think. So I think it's a good idea that we start that off now. So we'll go ahead and create it. Now, while we're doing that, we're going to continue on because we haven't exactly shown the monitoring. So we'll do a few things first. I'm going to jump into our cluster that already has a deployment in it. So I'm going to copy that command. And, oops, looks like it's not on my clipboard for whatever reason. As y'all remember, my kube cluster stuff is all named kube cluster, so it's so easy to modify this command to what we need. And we'll go ahead and browse to the cluster that we had set up prior to the session. So we'll give that just a moment. And again, because we disabled RBAC, or the role-based access control, it's become super easy to jump in. Now, remember earlier we created a namespace called IoT Edge QA, so let's choose that. And you'll see inside of here, I've got 2 virtual IoT Edge devices that have been deployed as pods within here. Now, if we want to be crazy, we can come in here and scale this up and do some integration testing. Go big. Warren just might not want to do that. So let's go ahead and we'll add another one. We'll go ahead and spin up a third one. And you'll see that updates the deployment right on the fly. If we want to monitor perhaps running workloads, I can click in here and view the logs almost immediately. Similarly, if I want to run a command, we can do that too. So you could come in here and do like a Docker PS and see what modules are actually running on that virtual device in the cluster. Now, I do want to take this time to sort of point out, like really wrap this all together. Let's go ahead and head back to the IoT hub that we created earlier in the presentation. And I'll navigate over here on the left to IoT Edge, and this will show us all of our devices that we have registered in our hub, which will go ahead and include the device that we just created. The one here is that smoke test device that was created in our earlier release pipeline. If we select that, you'll notice that it is also deploying the same modules in question. And again, those modules come from our previous deployment template. And so all of the steps that we did in Azure DevOps allowed us to create an automated form for us to take this in, modify it using variables that were stored in Azure DevOps, create that deployment, and apply it to the device. And you know, it's been quite a bit of time. Let's go ahead and check on that smoke test that we released earlier. And let's see if that has successfully built. And yes, oh my gosh, it looks like it was a success. We are rocking and rolling. That is a good feeling. Excellent. So let's go ahead and check out the logs to see a little bit more detail on. This will sort of explain what's going on here. It looks to see if the device is tagged with QA. What does that mean? That means that our device, if we look at the device twin, when we created it, we actually used some command line options that created this entry here that made it specify it as an environment of QA. And our deployment, if we dig deeper into Azure DevOps, is targeting devices with that criteria. And so now that we've gone ahead and done that, you can then start to see where if that deployment has been applied, we can start to look to see, okay, has it been applied? And once it has, are all the modules specified within running? And we just sort of check those one by one until we can confirm that all 4 are running. And that essentially is a good smoke test, because if, you know, imagine what, like, Ayse, what if we put in the wrong URL to one of these? You know, there'd be smoke.
So yeah, it would fail, right?
Absolutely. Yeah, so we wouldn't be able to pull it. So again, it's a great, easy way for us to check that out without having to go into details. Now, the final step that we're going to do is, and for instance of the time, I'll go through this very quickly. Now that we've got a specified deployment of something that we call Docker App Insights, that's going to allow us to capture insights from the Docker host that's actually instrumenting those virtual IoT Edge devices. And if you follow the instructions here, it'll show you how to create a chart where you can go ahead and gather in those metrics and also be able to specify alerts on them. So what that would look like, you'll see I've got that specified here. I've got myself a chart, and if I go ahead and click inside of it, I can then go in here and very easily create alerts. For example, like if this thing stops sending data, like maybe I want to know about that. And that'll give us the ability to sort of check out that our solution actually works over long periods of time. So with all that said, Application Insights has allowed us, this is a question for everyone out there in the audience, has allowed us to perform which function in CI/CD? Is that A, monitor long-running tests, B, continuous improvement, or C, continuous delivery? Now, Ayse, if you want to go ahead and explain us what is the correct answer here for question 3.
Yeah, as we just saw right now, we are using Application Insights to monitor long-running tests, and even we can create alert, which we mentioned.
Absolutely. So that is exactly what we showed off and exactly what the correct answer is there. So again, Application Insights gives us that extra ability to monitor long-running tests. Now, these builds are going to take a while. So we're going to kind of shift over to the summary, and then we'll get into a Q&A section. So I do want everyone out there to start thinking of questions you might want Ayse and I to answer, as we will move into a live Q&A session very soon. But before we do that, we're going to wrap up with a quick summary. So what did we see here today? We created a pipeline that ensures our builds are validated before changes are accepted to the main branch. We created a release pipeline after that then builds our module and applies the deployment to an IoT Edge device container instance, allowing us to smoke test the deployment. We then extended the release pipeline to deploy a set of IoT Edge device containers into a Kubernetes cluster to perform long-running tests. Now, of course, if you'd like to follow along with this material at your leisure, you can head to aka.ms/learn/IoT-CI/CD, where you can find the Microsoft Learn module that we've gone through today and replicate this on your own. Now, one of the things I want to call attention to, again, is remember, these modules are actually part of something that's called the AI Engineer Path that was actually developed by the University of Oxford. And there will be a number of sessions that are coming up through the month of October. In fact, another one happening tomorrow, which will focus on developing secure IoT solutions with Azure Sphere and IoT Hub, featuring Dave Glover. Now, one of the things I find really interesting about this, Ayse, is that you all have not only created these modules, but you're also leveraging these in the classroom and utilizing the Learn platform to do that. So I'm curious if you might be able to go into some detail.
Teaching some of the modules in the learning path, CI/CD is our next focus. The students have built hands-on and end-to-end solution in the class, and they learned how to build a model in the cloud, how to train an AI model in the cloud, and how to push them to the devices, IoT Edge devices. So they learn about what is IoT Edge, what is IoT Hub, and how they communicate to each other. So it was a logical progression for them. So like I said, the next step is CI/CD for us, and trying to understand the CI/CD and implementing CI/CD solution for the edge devices. So this is how our learning happens in the class.
That is amazing. And what I love about this is that because the modules are posted out to Microsoft Learn, they're really accessible to everybody. So not only are you able to leverage this in your classroom, but all of our attendees on the call today, and really anyone out there who has the spare time and the interest to follow along can really take advantage of any of these courses that you've made and hopefully become an AI engineer themselves. Again, we are taking questions from the audience. We do have approximately 8 minutes or so of time that we can spend answering those questions. So do keep those coming. We're seeing those sort of pile in. And before we dive in there, Ayse and I will just we'll go with a few more questions between ourselves, and then we'll start answering questions from the audience.
So yeah, I have a question for you actually. So this module in the Microsoft Learn, implementing CI/CD for IoT Edge, is implemented based on your original GitHub repo, and you are the owner of this repo. And I wonder what was the motivation behind creating this repo?
So that's a great question. So why, essentially asking, why did we build this repo that contains these best practices for IoT Edge and DevOps solutions. Really, realistically, I had been brought into a customer implementation for someone that was trying to do something, let's just say, offshore, out at sea. And they really wanted to be able to confirm that the deployments they were creating would be good by the time that they went out to these devices that were offshore, because they wouldn't have internet connectivity. And as you mentioned before, one of the great features about Azure IoT Edge is that it allows us to work in offline or intermittent network environments. And so utilizing the system, they were able to very easily pass this over to their quality assurance teams, determine that, hey, these edge workloads are good to go, and then they would cut the production release out. So excellent stuff there, that we were able to do with being able to take something that I saw in work, and now we've been able to create